So we're back again, and as the usual reminder, if you look under the YouTube video, under the description, you have to expand that out. We've got the index of this meeting that you're watching, and then there's a link out to our composite index that has several years of these all appended together into one big index. So you go search it, and it's a more convenient way to see what's going on. So anything that was in the description of this meeting that gets copied over to that index. Then I've got an index of the old original ROS agriculture stuff that I started one time, and it's not as fancy. It's just a text-based thing but you can still search it. And then if you cut and paste the link for the YouTube video, that will take you to the YouTube video. Otherwise, I think I'm the only one that has access to those anymore because the videos are all still there, but Matt deleted all those from the YouTube index. So it just says no data available for this channel or something. So anyway, that you can get access to those. I think there's a link to the Slack channel. And the last couple of meetings, I said I was going to add something else, and I keep forgetting what it was, and I don't do it. Maybe the Zoom. I was going to put the Zoom link in there, and I haven't done that. And there's a couple other things if you look through the stuff at the bottom. So anyway, that's just a way to try to tie this stuff together. Oh, there's also a link to our YouTube video index, the YouTube page for this. And so it's got all the little thumbnails for all these meetings, just like a regular, YouTube page works. And that and the index kind of tie together so you can hopefully, search up something you're looking for and make it do something useful. Hopefully this stuff is useful to somebody. I started doing this because I wanted to know what this information was, and I can make it work if I really have to. So let's see. And as far as things I've been working on, I haven't really done anything. Again, yeah, I was wondering about. I was back to my data logging stuff. I was looking at this stuff, and here's an 8266 board. So it's like an ESP32, but it's apparently it's the original version or something. And it's got on the front, it's got the processor chip and some IO pins. And then on the back, it has, come on, it's got a USB, or it's got a micro USB connector. Someday I'm going to figure this camera out, but apparently not today. So anyway, it's got a USB-C connector, and then that chip on there is the like an FTDI serial to USB converter. And I think there might be a voltage regulator on there too or something. So anyway, that's these boards that are slightly smaller. They have about half as many IO pins, and I don't know as far as the since it's an older one, the peripheral is going to be somewhat different. And then you compare that to the ESP32 boards. There's two different ESP32 boards, and they're basically the same board and the same functionality, but one of them comes with a micro USB, and then the newer one comes with USB-C on it. But otherwise, they seem to be basically the same board. And you can see the number of IO pins between the blue one in the middle is the 8266, and the other two are ESP32s. So that's just a comparison on what you can get there. And I was just thinking, I bought these ESP 8266 boards, and I'm thinking, well, for what I'm doing for data logging, I don't need hardly any IO pins, and I think it should work. So I was going to sit down and try to just put the code onto those, and they all use the Arduino IDE, so that should be they should work, and we'll see where I get with that. And then other things laying around. This is one of those ESP32 CAM boards. So it's got on the back, it's got an ESP32 processor and an LED that you can use to illuminate your scene. Everybody calls that a flash. It's basically an illumination LED. And it's got this chip on here. I assume that's probably one of those fast serial RAM chips. Because I assume what you do is you tell the camera, take a snapshot. Hold on a second. So you tell it to take a snapshot, and I assume you can then dump it directly into that serial RAM. And then once it's in there, at your leisure, you could write that, because it's got also on the board, it's got this ST flash card socket on there. So if you wanted to, you could write your image onto it. You just open a file and write it to that, and then you can come back later and you have all your images stored on there. Or it's got the wireless, and this probably has Bluetooth on it, and you can also use the USB. You could use, oh, this one, it doesn't have the connector on it. La, 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 la. Oh, that's the whole reason I bought these. I wanted a board that did not have USB because the code I had, it was just a binary that I could load on, and it worked exactly. It did exactly what it's supposed to. I was trying to do a in-trip server, so it goes out the internet and connects to a correction server, and then it's supposed to take that and then output that out the first UART. Maybe it's the only UART on the board, and if you got one that's got the USB, it's got the UART to USB converter. So it was dumping all the data out the USB port. That's not what I wanted. I wanted it to come out a physical UART so I could hardwire it directly to my GPS board. And it turns out if I bought this board, this is the only board I could find that didn't have the USB built right into it. So I ended up getting that. And then you can also buy that board. So here's a board that's got the camera stuck on there. I think there's some tape on the back of that. So if you want, you can just press it down on top of that ST flash card socket there. And then, it just, you can get various code from various people to make this into a camera. And then, as I say, so basically, I think it's going to take snapshots and send you the individual pictures because I don't think you can do streaming video with this board. But if you want to do streaming video, just get a Raspberry Pi and um, on the Raspberry Pi, you can either plug in a web camera or you can put in the Raspberry Pi cameras that basically they plug in like that, where it's got, a little cable that plugs into the board. And I don't know if these are directly compatible. If I can pull this out and put a Raspberry Pi camera on here, I just haven't dug that far. And then, so you can buy it like this. It comes with any of them you buy. I think they come with a camera, and I just took the cameras off the other two. And so it's got the little board. It's got not too many IO pins, and a lot of those you can't use anyway because the like 4 or 6 of those go to the ST flash card sockets. So if you want to use that, you can't use those IO pins. And there's something else on there that some reason you can't use the extra pins. But then you can buy it like this, and you can buy the baseboard for it. So you can just plug these two together, and then this board has again, it's got a micro USB connector, and then it's got that FTDI type converter chip on there. So basically, this is just a way. And if you're developing, you can just, when you want to program it, you just plug the board in. So just you plug the board into it. Now you got a stack like that, and then you can plug in your USB connector. Where did that go? Yeah, of course you can't see it. So there's a USB connector on the end here. You plug that in, and that gives you communication and it gives you power. So that's a convenient way to do it. And if you don't want that all the time, then you just unplug the board. So you're back to this. And see, I've got jumpers plugged in there because that's either how I was programming it or that's how I was talking to my GPS board. So basically, you put power on it, and then you can use the UART stuff coming out of it to do that. So anyway, that just various variations of what I could do there, and those are all fairly small, and they're not really all that expensive. So I was just looking at that 8266. I think I bought 5 of those. So I started out this data logging stuff. All the tutorials say, "Oh, use an 8266, and if you get the one that's the WeMOS or the whatever they called it." So I basically, since I normally just take the path of least resistance anymore, I just said, okay, I'm going to order that particular one because the tutorials say that one will work. So theoretically, I can just hook that up to something and load the code, and it should go. So that's some other things I can try here one of these days when I've got nothing better to do. I did order some more of those new humidity chips. I just ordered those last night, and the ones that I bought 2 of them originally, and they seem to be doing what they're supposed to. And one of the things I wanted to do was hook up several and run them all at the same time, so I can compare them directly and then plot them out and say, is the humidity on each one tracking the rest of them like it's supposed to, and the temperature, are they tracking each other? And in order to do that, I see the ESP32 seems to have one I2C port, and I don't know if you can do an extra software one or not. But the thing is, these humidity chips have it's an I2C interface, and you can switch it from one address or another address. That's your only 2 options on the thing. So if I end up with four new ones. I got two old. That means I got a total of six of these chips. And so what I did, I went out and bought an I squared C multiplexer chip, and I found some on eBay, or not on eBay, on Amazon. I found an 8 channel board, and you can get them anywhere from one board for $10. I got six boards. I think I ended up with six boards for $10. And it's just a matter of you hook that chip up to your I squared C interface, and then you have to add a couple extra lines of code that say, tell the multiplexer to switch to channel 0, and then you can just talk normally and you're talking to the first interface, or say, send out a command and say, okay, now switch to channel 5. And again, you can use it normally. So theoretically, I could get up to 8 devices that all have the same I squared C address, but the multiplexer switches around so you don't have to do anything funny. And the first ones I hacked on one of them for about an hour until I got the little jumper thing cut, because they said cut this trace and then solder this blob on here. That's what everybody tells you to do. So I fought with that for a long time, and I finally got that one to work. So those two boards are just blatantly in parallel, hooked up to a thing. And when I run the code, I say, go to this I squared C address and read the value, and then go to the other I squared C address and read the value. And that seems to all work just fine. But now I've got a whole bunch of them all at the same address. I'll just use that multiplexer. And that's probably all I need that for. I just want to find out, uh, with this handful of chips, are they all close enough that I can say plug it in and trust it, and then go from there. And other than that, I had some of these a long time ago. I had some 4 channel multiplexer boards, and if I dig through my boxes, I could find those. I just thought it'd be quicker to just order new ones on Amazon. They're supposed to show up by tomorrow, so I might have some more on that later. And probably at that point, I'll have a couple more comments on, how you use that multiplexer chip, and the fact that I've modified one of my boards to a different address. That shouldn't matter. I should be able to still plug it in and then switch to that channel and use the modified address, and it should still work. So that's just kind of where that whole project is right now. So that's I'm going to say that's all I have for this week.
Well, I will go, Bob, if that's okay. Jeff, can you hear me?
Yes, I can.
Yeah,
Okay.
go ahead.
But this is my Miro board, and I don't mean to bore you, but just as a brief reminder, I've got a base station that's outputting on a web address and port of that, and it's picked up by my RPi, which is running this piece of code called RTM server that's out on GitHub. And its function is a number of things, but one of the functions that it performs is it takes this correction data and feeds it to one of the GPSs in order to get RTK fix, and it's also taking the heading data off of one of the F9Ps and feeding that into another UDP port. And I do that because using that port was, or using WebSockets and ports was the way for me to communicate with multiple things simultaneously. Ultimately, that'll feed into a pure pursuit navigation program, but it doesn't do that yet. So I've got 3 ways to get input down to my low-level controller, which is driven by a Teensy board. One way is ultimately going to be, for most of the operation is running pure pursuit, which feeds commands to the Teensy. And in order to do that, to get from the RPi to the Teensy, I'm doing that over a serial connection, but this script called a Teensy serial bridge is running in order to get that data. So that's going to be one way. The other way is if I'm in manual mode, This is my little rendition of my radio control, which is connected to an NRF 24 radio. That's also on um, my tractor, but connected to the Teensy. So that's the second way. And what I've been working on is the third way to do that I've represented here on this box, which is a web, I'll call it a teleoperation control console. And so previously, as I posted in Slack, I had just learned enough about this WebRTC that Bob introduced me to and wanted to sort of figure out, well, how does all of that work? And I think I went through a series of tests, and all this code is in my repo. But um, I started off with just hooking up a USB camera, uh, and I worked my way through changing that to an Oak camera, and now this teleop console is what um, I'm most recently using. And so out on Slack, what that looks like is, one web page that's being published. It's just on 8080 channel. I think they say channel 8080. In the middle of that is the video. This happens to be sitting on my kitchen table in Pennsylvania, looking out the back window. And along the bottom are is a slider bar and presets to control the steering, and along the left is presets to control the speed, an emergency stop button, and a little bit of telemetry data here, and a little bit of telemetry data here. Um, so previously, when I was messing around with WebRTC, these control commands, when changed, would go to my RPi, which connected to the RPi was a PCA 9685, I think, servo controller connected to servos, so I could show that I could control those servos. So what I've been working on is getting those control commands to flow, going back to my Miro board, to flow from the web interface through this Teensy serial bridge via USB down to my Teensy 4.1, which is looking for commands like this linear X and angular Z, which is a carryover from ROS days, um, which would ultimately control the steering motor, or the linear actuator, which controls the transmission, which I just noticed I don't actually have on my board here. So where I'm at the moment, going back to Slack, is I've got two pages that are being published. One is this, what I'll call control page, which again, speed on the right, steering on the bottom, emergency stop. And then I also, let's see, created another page that I get to, through this URL /dashboard, same IP address, same channel, but it's just /dashboard. And just to start off, I put a map on there. Ultimately, I'm thinking, hey, if I get my navigation working, I would put, the actual position and the path that it's supposed to follow there. But along the right-hand side is, a number of telemetry pieces of data, like what's going on with the radio, what's the steering data, and what's the transmission data. So what that looks like in practice is, I happen to be puttied into my tractor, and the code is sitting on that sitting on that folder. So now if I go back up here, at that point it couldn't connect. That happens to be my local address. But if I refresh that, it's going to come up, and there's the, you can see the heading is pretty stable. There's two antennas in the back, running the wires through that window. Happen to be getting fixed at the moment, which is a good thing. And let's see if I open up another web page.
I wasn't paying real close attention. I just noticed I could see your like flower pot swinging outside your window. So I didn't realize we were watching a live image until I saw that. Now, have you experimented with, say, different resolutions on your camera? Because that right there looks like a really nice image coming across there. But I'm just wondering.
I
Um,
have not. It's a out of the box, one of those oak cameras.
yeah,
I've forgotten the model, but
I'm
uh,
thinking there's probably settings somewhere to say, well, use this, set it to this resolution or this resolution. And if you run into a problem. So anyway, my I guess my point is, I don't know. Let's see, does that tell us frame rate there? So depending on your frame rate you want to send um and the resolution you set on the camera, you can play with all that stuff and control how much bandwidth it's going to take to move your video back and forth. So do you run everything over the same channel on your Wi-Fi, or is this not going over Wi-Fi at this point?
this is going over Wi-Fi and being published on this port.
Okay,
And so I'm getting video and control over this port.
okay.
This,
But that's just things to look at in the future if you start having problems or want to experiment.
and so the other page tab is what I would say the dashboard. So I'm anticipating having two monitors, one with this up and one with that up. And obviously if I lose RTK and need to control it, this is the page I'm paying attention to. If I'm just monitoring things, keeping an eye on things, then this is the page I'd be paying attention to. But so a little bit of progress. And again, um, it's under this folder WebRTC, and the reason there's multiple scripts there is because, and I didn't plan it this way, but I started with this and I ended with this. This was just simply using a USB camera and progressing through getting two-way two-way communication and control. So uh, I think that's about where I'm at. I was in Texas. I'm back in Pennsylvania using my RTK. I had to fight through a number of different errors that I was getting in corrections. So one of the things on my base station is I have to reset I save data on this ESP32. There's also an ESP32 connected to this RPI. And yeah, I was fighting through some changes on that, but yep, that's where I'm at the moment. Over to you, Bob.
Um, oh, I've, I've been crawling along developing using ChatGPT, and then Al suggested a script that he generated, and I ran an exact script through Claude and GPT. The Claude evolution took quite a while, but it came up more like a corporate document with all kinds of color and boxes and this and that. The one with GPT was just straight code, nothing, no fancy graphics. Let's see if I can change screens and go over to Chat GPT. And I want to share this screen. Okay, and share. Okay, now I want to go over to the chat. Can you see that coming up?
Yes.
Okay. I'll get that out of the way. Over here on the left side is all kind of my thrashing around in the water, trying to figure out what to do. Let's see. And then finally, I went down the path of just individual chats. But I needed a way to track them because I was down here. I was losing track what was where, and there's some nice tips and diagnostic commands, and I was losing track of where all that was. So then I came up here and it started. Oh, let's see. Come on. There's more. So then I went into individual chats. Oh, here we go. One of my flailing in the water was developing the program suggested I do an archaeology looking back through projects. Well, then after that, then it said, well, here's a good architecture in it to give you 3 files. A body, which would go on the Pi, the brain would go on the Nano, and then something called an index file, index.html. And that gives me the capability of looking on the iPad or any browser. So then I went in, started focusing on the body part. It kind of takes a while for it to come up, I guess. And so it kind of lays out what to do. And I can take at this point, I can take each stage and not time out or for the number of tokens I've been using. But as soon as I get a good solution, then, or I want to evolve the program, then I go over here and I want to keep track of what chat I was using. So the first number is, this is still chat 1 here. This is still chat 1. And this is chat 1, but it's different versions. As I get feedback from chat, I evolve that thread. And at this point, I think it said I was pretty much okay after developing the body. So now I went up to start working on the brain. So I call that chat 2 because that's the second program. And we're developing the program, the Pi program. And I listed it, well, this is version 1.0. And Al suggested putting the date in to keep track. And so that's what I did up at the top. So I got a date, and then I eventually started putting in the time because I was losing track which one it was. And let's see, that's about where I'm at, I think. I then ran Al's script both in chat and in GPT, and it came up with a plan. And Al just helped me this morning to create a new project, but keep everything in under there instead of a whole mess of chats. Let's see if I can find it. I I think he called it Bob's robot. So it'd be down in or up in projects.
Bob, I was on my account when I created that. I didn't create it
Oh,
under your account.
okay.
You'll have to do that yourself.
Yeah, I'll do that then. So at this point, um, I'm considering whether just developing the robot around the Raspberry Pi to get something up and running, and then slowly develop the nanobot with the camera and stuff like that. So that's about where I'm at right now. I learned a couple of things along the way. It mentioned putting what it called a test harness. So at the bottom of the project, if everything is good, then you can go to the next stage, and the next stage can interact with that first stage. So it's a way of kind of locking one stage until you're done, until it works and there are no problems. Then it automatically will open itself up so you can develop the second stage. And up to this point, I didn't have a very good feel for sockets and ports and all that stuff. But the more I use this, the more I'm getting comfortable with what to look for. I had one problem. I couldn't get my motors going. And then it said, oh, don't forget the port number on your brain should be the same port number on the body. And sure enough, they weren't. And that was one of the problems. Previously to that, it offered a number of different pins on the Raspberry Pi to connect to. And then I said, well, no, I want to use the hardware designated pins. And then so it said, go to this pin, go connect to that pin, that pin. And I just read it. Oh, just go to the pin. Well, they were talking GPIO pins and not board pins. So I have to, in each reply, I have to designate, just give me the board pin numbers, because that's easier for me to count pins and plug them in. So that's about where I'm at right now. I think under the old system, the Pi controller is pretty much set. Now I have to work on the brain and get that talking to the Raspberry Pi. And I don't know whether to at this point, I'm not sure whether to keep going or just stop and just do the Raspberry Pi all in one program. But one thing I do know is if I ever do add the Nano, I have to have two programs, one running on the low controller, and one on the Nano. So it's all in one is probably be easier to work with, but I'm not sure about troubleshooting. If I suppose I'd have to come up with a way of separating each stage within that single program to get that going first. So that's about where I'm at. Now,
So Bob, don't change that page. You're
okay. Okay.
You're going to control this over a browser. Is that what I'm picking up
Yeah.
there? When you've got an
Yes.
IP address there, and
Yep. It would be over any browser, but primarily the iPad or the laptop. And I am able to go in. At one point, I was able to go in and I could see things. I had the video showing live. Underneath that were a series of buttons for speed, with the top speed of 14% all the way down. So it was really slow for the inside robot. And then I had two what they call D pads, like a game controller, where you had arrows where on the right side it was forward, reverse, left, and right for the motors, and on the left side it was for the pan and tilt and up and up and down. And I started having some problems with it, and I said, "What's going on?" And eventually, I found out that two of my cheap servos crapped out. So I have to take that whole servo assembly apart and put the good ones together. Because on one I could pan left and right, but I couldn't go up, and on the other one, on the web camera one, it was just the opposite. So I have to take those apart and realign them, and maybe find some other servos to replace them. But
And so right now are you using that PCA, whatever it is, 9685 servo controller?
yeah,
And
yep.
that's connected to your Raspberry Pi?
Yes.
And then your motor controller, I don't know, IBT or
Yeah,
MBT,
the
whatever it is.
MND10 is connected to the Raspberry Pi, but to the GPIO pins.
Got it.
So it's coming off the Raspberry as IC squared for the servos, and just other pins controls the motor controller.
And so this command menu here, forward, back, left, right, that's for the motor controller that's
Right.
connected to
That goes,
GPIO pins.
yeah, that goes strictly, through the GPIO down to the MMD motor controller.
Got it.
And of course, that motor controller has test buttons for forward, reverse for each channel. So I can pre-share map. And then I've had to use a notebook quite a bit because one version will say, "We'll hook this to that and that to this." So I just made a graph saying, "Well, here's DR1 and pulse width 1 and DR2 and pulse width 2." And then I color coded the wires. And I've gone through about 3 revisions of which pins to select to, but now I've got a pretty good handle.
So this code on the screen now, have you ran that on your Pi?
No. Last night I decided to just stop. At the top of the screen, you'll see the body IP port 192, 168, 150. That was a bug problem. It was trying to connect to the body, but that's the wrong IP address. The one for the body is 192, 168, 4, and 153. And then, of course, the ports were screwed up. That body port wasn't accurate. So I had to go back in the body and find out what it was. And I started a new, I took this stuff and put it into a word processor and then made the changes in the word processor. So I changed the body IP and the body port in the word processor. And there's a few other changes. And then I copy that Word document and paste it into my new chat that I start, and then run that program, and that generates tips or errors or even what I should do next. So it's a cycle of going from chat to word processor back to chat. And I've been trying to develop a chart, so because I get confused sometimes where I'm at. So
I get confused all the time.
So
Well,
I think in
not
this, yeah.
well. I was just going to share something with you. I There's a program called Filezilla,
Oh, okay.
and what it lets you do is log into your so on the right hand side is my tractor,
Okay.
and on the right hand side is my Windows, happens to be my Windows machine. And you can go into your, if you can find it, there it is. So like these are the programs that are running on my Raspberry Pi.
Okay.
You can right click those and say edit. And
Oh.
what it does is it brings down a copy of your code on your Raspberry Pi,
Hmm.
puts it in a temporary place. And if I just, make a change here and save that. Now, if I close this, FileZilla is going to ask me, hey, do you want to post this back to your server or your Raspberry Pi? And I say yes.
Okay.
So now you'll see, well, that time and date hasn't changed because it doesn't automatically refresh the window. But now that I've
Yeah.
clicked refresh, it has. And so you can see this is now that version that I put those two letters in the.
Okay.
So it's just a little bit easier workflow than copying stuff into
Yeah.
whatever you were copying it into.
Right.
So this is called FileZilla.
FileZilla. Okay. I'll have to look at that then.
Not that I'm not meaning to confuse you. I'm just trying to show you another way of
Oh no, I need all the help I can get.
editing stuff that's on your Raspberry Pi.
Yeah. Um, so that's about where I'm at. I've got some things to do before the snow comes tonight.
So
But
back to your,
my electric snowblower is working pretty good. The only problem I'm having is there's a lot of small rocks that it finds every once in a while. So I keep the blower on a lower RPM so it doesn't blow as hard as possible. And then the rocks kick out. And I don't think I can automate that thing because of the rocks. So I imagine I could come up with some way of controlling all the controls on it. But the fact is that when I know I'm coming up into a rocky area, I have to tilt it up. So that's one project I don't have to work on or think about.
I'm all set, Jeff.
instead of raising the snow blower up, you could have like some kind of brackets that hang down, some kind of feet that come down. So they would just simply, when you engage those, it just raises the front end up. So as you drive
Yeah.
along, it just, although that if those are falling into the spots in the rocks or something, that may not work out as well as I'm thinking right now. But that,
Right.
rather than getting too wild, we'll just have something you add on that even if you had clamps or something to hold it, you could test it by just getting some little spring clamps and then
Sure.
putting something for feet and then clamp them on there and see how well it works. If that works, then you could figure out some way to mechanically make it do that.
Yeah.
So that just might be a way to get around that. And that way,
Yeah.
you set it so like you're an inch off the ground, and that way it's still going to leave an inch of snow, but it'll move the majority of the snow when you do that.
It has some plastic skids underneath, and I've raised that up So it's doing what you just said. It's
Yeah,
leaving
yeah.
about an inch, but I still hit 1 inch rocks every now and then. So this spring, my major project will be to loosen up all the ground and try and rake out the big ones and then pack it back down.
Could you use some kind of a roller or something, or just drive back and forth with your car so it just presses them all down in the same
Yeah,
height? Are they going to work their way back out? I suppose.
yeah. The rocks are river rock. They're about an inch to inch and a half, and they used it right before the concrete apron, the driveway, because underneath is about a 3 foot trench and filled up with that rock, and then that trench helps drain all the wet from accumulating around the house, and it feeds it downhill towards the lake. But with all the traffic, the rocks get kicked out and made loose.
Yeah.
I'll have
Wonder
to
if you,
take a I'll have to take a picture of the mess.
I wonder if you could somehow flatten all those rocks out and then put some kind of adhesive to hold them together. If you
Yeah,
get too much adhesive, then you won't get the water flowing through. But there's
yeah,
just something to keep the rocks from moving around. But that might make more of a mess than it's worth,
yeah,
because you get them glued together and then something screws up. Now you're gonna have a bigger problem. You get big chunks of, big chunk like this of rocks that are all glued together that
yeah,
are now a problem. So that could be that.
yeah.
So maybe don't even worry about that.
Yeah, it depends on how much money I got.
Yeah. And how much time you want to spend, because it'll take time to do it. And then after they get all glued together, now you're going to have to spend the time of, well, now I'm going to take a sledgehammer and break them apart again to
Yeah,
get back to where you started. So,
yeah,
so back to your comments about your RC servos. You said your crappy servos are not working. Just as a
mhm,
debug step, before ripping it all apart and having to recalibrate everything, is just unplug the one you think is bad and plug a different one into the
yeah,
same spot and verify a different servo is going to work before you take it apart. Because it could be you take it all apart and put it back together, and it's still going to be doing the same thing, because maybe it's a software problem somewhere,
yeah,
or there's all kinds of things that could be wrong with it. So just just as a debug step, there's things like that you can say, oh, before I put a lot of effort into it, you can try substituting things out or moving things
yeah,
around or whatever. And, no matter what you're doing. And then in this case, it happens to be, you're talking about an actual RC service and that's not working. And also if you had one of those little RC testers, so you could feed a different signal into that existing RC servo to see if you can move it manually. And that
yeah,
way, again, that might eliminate if it's software or your wiring or something else. So, and so speaking of time, that could save you a lot of time by doing that kind of stuff.
yeah. Um, I've also gotten in the habit of, like with those servos, I'll put some red tape on the ones that are questionable. So now I can do a much finer diagnosis.
Yeah. And other that on those servos, just the fact, try different ones before tearing everything apart, and try to verify if it's,
Yeah,
and you said you had some really crappy ones and then some better ones, and I don't know, what the difference is between those. It could be that, whether they're crappy or better ones, whatever the real problem is may come up anywhere. So
sure.
that's all I can think of on that. That a lot of this debugging stuff. Once you learn these techniques, and it doesn't just apply to RC servos. It can apply to anything else. That just get in the habit of thinking about, well, what is, rather than tearing everything apart. What could I substitute in, or try it a different way, and
Yeah,
that'll tell you whether it's what you think it's the servo itself is bad, but it might not be. It might be something else.
yeah.
Well, that's all I can think of for this week.
Yeah. Same here.
I'm good.
Yep.
Okay.
Thanks again, Al, for helping me get
No
my
worries,
laptop
anytime.
online.
Okay, I'm going to stop it now. Stop recording.